Hey everybody, hopefully you can hear and see me right now. Can everyone who all is online, who all can hear and see me? So we should be started now. So let's see if I can see who's in the chat. Sometimes it lets me see the participants. It doesn't show me, but it does say people are watching. Yes, Christian, so good to see you. Jessica, yes. Christian again. So we started 1 minute late here. Sorry about the late start. Whenever you see that I'm playing the intro screen, Quinlan and Nicholas, good to see you all. So whenever you see the intro screen, I am broadcasting. So that's like, it's not like YouTube does that. That's me actually. Hey, Yulia. So good to see everyone. When you see the intro screen, I'm actually here. I'm just kind of like getting everything set up. John, good to see you. Good morning. So we have everything good to go. And yes. And so I think I'll be in a green screen. So yay! So then I'll be more like I can actually maybe move throughout the screen. I don't know. Might have to reorganize everything. We'll see how everything goes. But I've got everything pulled up right here. We'll start working on the lab here and going over the concepts from this week. So very important that we actually know what is going on. I can't state that enough that utilizing what we're learning is the most important thing. So I think all our brains are turning on. So sorry if I'm a little bit slow as we do this right here. But let's talk about what we got going on and let's go over the lab. Okay, and remember, in chat, ask questions at any point. So follow along, watch this video. We're probably going to do the whole thing here, but just ask questions, and hopefully other people are watching this too, getting some help for understanding this material. Okay, let's go down here to this screen, and let's take a look. Okay, so we have right here the package we'll be using. What I really like about the new jump, not the new jump, the new R in RStudio is that when you don't have packages, it will have you automatically load them in. So I should have all these packages. This is a predictive package, I believe. Caret is your classic classification, association, regression tools. I can't remember the T of it. Training, maybe it's training. And then E1071 is used in some stuff. And then red class is Dr. Petrie. And sure, it was built. Oh, have I not updated this R? I've got my laptop. I've got my other laptop. I've got this one. So I'm not gonna. That's a little bit interesting. Hopefully, if you see something weird with the answers, tell me like as you follow along. But I think I'm running because you can see what R version you're running by just going here and running r.verge. And we have everyone update, so that should just run right there. 3.6. I installed R on this computer when we got it, and I don't do a ton of R on this computer, so that's why this R is not updated. So looks like I need to update this version of R and get 3.6.3, which I think is what everyone else has. But I don't use this computer all the time till now, and so I am running an older version of R, which we don't like to do. So that's interesting. Thank you, Warning, for telling me that. We've got Caret, and we've got right here. And it looks like everything's working, but it's just saying that these packages, and what are packages? They're things made inside of R, so they contain files, they contain functions, they contain a lot of stuff. So there we go. Every time you need to use setseed, please use 2019. We will inject the same type of randomness into our code. If, for some reason, people are getting way different answers than me, I might just reinstall R today. Like I might... Let's take a vote. You know what we can do? I've actually got the ability to vote in chat now. Where's my button? Let me go up here and let's take a vote. Let me add a poll. I'm going to try this. Okay, title. Options. Should Brian install R now? So let's go here. Option 1, yes. Option 2, no. And does that do it? Well, I'll be. Use timer, duration. We're going to put a 30-second duration. And then, why can I not click done on this poll? Title, add. Oh, there we go. Oh, okay, wait. There we go. Morning. John already said morning. Add that. Okay. Now let's add this poll. Done. Okay. Did it add? Start poll. 2 seconds and we'll do it. Did I add it? Pick an option. No. Cancel. Add a poll. Should. Oh, good, good. Oh, no. So wait. We might do it that way. I'm trying out new things as we get started this morning. Yes. Okay. Now it should do it. So let's see if it does it. There's only 60 seconds. So you have to use vote, and then you have to go here, and you have to do an exclamation point. John's already voted. So go ahead and vote. There's only 60 seconds on this. And, oh, I didn't put 60 seconds in, but go ahead and vote. John's the only one who's voted. So it looks like I am reinstalling R by the John's vote. So, and I'm going to I can put things on here that would show it. It's looking like yes, Yulia's voted yes too. And so this is really helpful with like my bigger classes because I can have them all vote now. Well, this is unanimous, but it's pretty cool. I'll show you guys what's going on right here. But when I do voting, I can pull it on this screen. Yeah, I'll screenshot it. I never know what has like, don't broadcast this because then they'll get your code to broadcast online. Wait, what happened? Why did that image do that? It's really kind of cool because I can see what people are voting. So it's unanimous, and it updates like every like 10 seconds. So, oh, and then when I close the poll, it'll actually say what the vote percentages were. So I can do votes in the chat, tallies all the votes. Okay. So let's do that. Should say the results of the poll. Should do it. Just takes a moment maybe. Okay, so let's see. Okay. So give me, I think I can do it right here. Let me do this. Download RStudio. Okay, so we need to close out of R. So let's we'll put this in the background right here. So, and then we need to close out of R. Don't save all those. Okay. So, does it not show the results of the poll? It did yesterday. So I'm still learning all this stuff about Streamlabs and everything. So let me download R first. Oh, there's a new version of R coming out. So, how's everyone doing this morning? 3.6.3. Is everyone doing well? I'm gonna download this. What are you guys and gals up to? We should be started here in just a moment. Get this newest version of R on the computer. Updated 2.29. So maybe I'll have a newer version of R than everyone. Uh-oh. Makes it random. It's doing. Need breakfast. Go grab some breakfast real quick, John. Grab some. What is a good breakfast? Grab some orange juice. Grab some eggs. Make some bacon. Yes, yes, yes. Preparing to install. Coffee and cereal. Coffee, that's good. We should take a vote. We should, let's take another vote while we're doing this. It's a fast computer, so I might not need votes. Let me try this again. Say, like, what is the... Okay, so here we go. I just made a poll is currently underway. Oh, complete. Oh, there we go. I didn't complete the last poll, so I'm learning as I do this. So now I think it'll say, aha, you already know the answer, John. Oh, it already opened that last poll, did it? Yeah, there we go. So it's got the commands right there. There's cream and sugar, there's black for B, and coffee is gross. So apparently when I do like CS, but Haslam Saturday 1.0, I like that kill right there. So there we go. Yeah, so here's the new poll open right now. You can vote for Cream and Sugar CS, Black Bee, or Coffee's Gross with Gross for Gross. Caleb votes coffee is gross. So it's kind of neat right here, and I can see the votes as they come in. But yeah, I'm totally figuring out. It's so neat, and I can. I'm gonna figure out how to get this on the screen so you can see it, and so I'm learning as we go and learning how to do like the online streaming thing with like polls, but it's probably better. I'll remember capital B, capital B. Ooh, I think actually I'm wrong. It registered the lowercase b, Quinlan. You taught me something because you're the only one who voted it. So I learned that the lowercase b also registered. That's interesting. Didn't know that. Thank you, Quinlan, for 1,000 points, Quinlan, or 10,000. We've been throwing out 10,000 lately. Everyone voting 10,000. Okay, let me get the latest version of RStudio, and then we'll be good to go with this. So for anyone watching, you can always fast forward this. And I'm downloading the latest version of RStudio. It's barely off the side of my screen. I've got multiple screens. So RStudio, and this should just update RStudio. Da-da-da. Installing RStudio. It looks like, here we'll go, close poll. So I can reopen the poll. So like you can close the poll and reopen the poll. See, then I can like reopen it. So I'm just trying this out right now as this is doing its thing. So I'm just closing it and reopening it. And so it does that, it just like reopens the options. And then we go to complete, and then it should say the results. So I've completed the poll now. And it does say the full thing. It says Cream and Sugar. That's pretty cool. And there's other things you can do too. So I'll be learning and experimenting with this and trying to figure out like the best ways. But when I ask questions, I can do a poll and then it can tell me the most voted option pretty easily. Pretty neat. That is pretty neat. And I've got, what is this? Oh, that's the video. Okay, let's close that. Okay, so let's hope we've got the new RStudio on here now. Let's, mouse is just so weird. Let's hope we have it right here. We'll see what happens. Okay. Oh, there's where I was doing times tables and all that stuff. And there we go. Here's the lab. And let's go to R version. I think it even says it when you start. Hey, we got it. We're good to go. Okay. We have updated R. It only took about 5-6 minutes. So let's do this. Okay. So AUC is a huge concept. AUC is something we've talked about repeatedly throughout the class, and I just want to make sure we're on the right one. Yep, we are on the right. Good. And so AUC is area under the ROC curve. So what is the ROC curve? It is the receiver operator curve, and we need to make sure we've got some knowledge in our heads when it comes to this. So let's open up a new Word document. I'm going to go up here, and there we go. So what are we talking about with AUC? AUC is area under the ROC curve, and an ROC curve looks like this right here, where we have the ROC curve, and it generally looks something like this. The area under the curve is this. What is the maximum value for area under the ROC curve? Who knows in chat what the maximum value for area under the ROC curve is? Any ideas what the maximum value of area? It is 1, David, 10,000 points. Nice job. It is 1, and that's what you want. You're looking at your true positives to your false positives. So that's false positives right there on the bottom. And you want to see that you don't have to go through many false positives to get all your true positives. The goal is that your curve, the ideal curve, is a curve that goes straight up. You'll rarely ever get this and goes like that. And then you would get an AUC of 1. That is the ideal for the ROC curve, and that'd be the value of AUC. Think about this. It's area under the ROC curve. This whole thing is the ROC curve, and then the shaded area is the area under it. Like this is the AUC, and this is the ROC. As in, that is the receiver operator curve, and then the area underneath it is the numeric value. So here's the crazy thing, is it goes by both names. Is that you might hear AUC and someone's talking about this, or you might hear ROC and they're still talking about the same thing. So codes kind of use them interchangeably at times. It's kind of a bummer. You just have to be like, okay, it's the same thing. So, but it's AUC, ROC, either one is fine. is often used in business analytics to gauge the model and tells us how the model ranks probabilities. If a company needs to select the 500 customers most likely to do something, then the higher the value of the AUC, the better the model will be. The numeric value of AUC can be interpreted as follows. If a random member of yes class is selected along with a random member of the no class, and the model scores both of them, the AUC tells us the probability that the model will give a higher score to the member of the yes class. And that is key right there. And we looked at this yesterday also, so we're kind of doing a little bit of lecturing while doing this because we're not just going to give away all the answers. So it's important to know that follow along. Don't just write down all the answers that I'm about to give as we go through this. But when you think about a good AUC would have all the yeses up here with the highest probabilities. So this would be an AUC that would be the highest, because all the yes classes get probabilities higher than the no class. Like if this is 100% probability right here, and this is 0%, even though, and let's say like this is 50 right here, so that'd be 50-50. Even though there's a yes class that is going to be said to be no, all the yes classes got a probability higher than the no classes. So this would not have an accuracy of 1. Does everyone see why this would not have an accuracy of 1 or 100%? Because this one right here is misclassified, but it has an AUC of 1 because the yes class always receives a higher probability than the no class. That is that definition I just read right there, that it's the probability that the yes class receives a higher probability than the no class. I know I'm saying probability twice, but I'm talking about, we're saying this person has a 100% probability of buying, this person has like a 75 probability of buying, this person has a 60 probability, and we're kind of ranking them in order, and it's the probability that the yes class gets a higher probability than the no class, and in this instance, the yes class always has a higher probability than the no class. And so this has an AUC of 1 because you would have to go through, if you think about the AUC curve on this, you would have to go through none of your false negatives. The curve would literally just jet up like this and go across because you would go through none of the false negatives to get all the true positives. Here's your true positives, and you would go through none of these. You'd get no false negatives because by the time you get all the true positives, you're done. Remember, true positives is already at 100% right here. It's a different 100% than the one beside it, and you go through none of the false positives. Who thinks they understand this really well? I just want to see in the chat, because this concept took me a while. Like, but who's like, oh, I get it, that like, if you were to go through these, you'd get none of the false negatives. Now I can change it, so we wouldn't have an AUC of 1 if I just make this right here like a no, and now you have to go through some of the false negatives. Because now when you go through and one of them is misranked, sort of, it's a tough concept. I totally mean this. Like, I can't tell you guys and gals how many times, yeah, you got to go through it multiple times. That's why I don't just do it once and like, well, you heard me say it one time. But you're going through the data. Keep asking questions if you got it, but I swear I learned this in undergrad. I went through it in grad school, and it really took me teaching it to be like, oh, I understand it now. That like it's what percent of the false, like this graphic literally represents, like right now, the graphic now would probably look something like, here's what it would look like. We only have 6 data points, or yeah, 6 data points. So you'd really have like, you would go through this, and then you'd go through a false negative, and then you'd go like that. This is what the curve would probably look like now. And it'd be a very good AUC. So this would be a pretty good AUC right there. Do true positives have to be yes? Yeah, it's just whichever one you're predicting, the predicted class. And the reason it's often yes is because, remember, so Christian, great question, 10,000 points. It's often yes because in logistic regression, in logistic, the level of interest comes last. So anytime you do yes, no, then the level of interest is yes. So since we're predicting yes, but there you go, logistic level of interest comes last, you're right. So if it is yes, no, then it is yes. You could switch it. I mean, you can trick the program. So, you can just change the way it does the math, but generally speaking, it is it's the last one, and you can recode variables though. So, but Christian, pretty much yes. It's the way most answers are in statistics. It's like generally yes. So we're going to write pairwise AUC. Yes, we're going to do the AUC. So hopefully this helps us better understand it, which takes the two argument actual, a vector of class actual labels and predicted, a vector of scores of probabilities given by a model. So think about what we have right here. This is literally, let's show what we're doing right here. This is literally what I'm doing right here. We've got, it might look better, I'm going to erase it. We're going to take two things. The two things we're going to take is we need a vector, let's think about what a vector is, of like actual classes. So we have right here the actual class like yes, yes, no, dot, 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 and then like yes at the bottom. That would not be good. And then we have another vector of probabilities. So from the probabilities, we can get the predicteds. So this one might have like a 99%. Of course, it'll be point. So let's fix that. So it might be like 0.96, 0.92, dot, 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 dot. We're going all the way to the bottom. But we have two vectors right here. And this would not be a really good AUC. Who can tell me in the chat like two reasons right now why the AUC is definitely not perfect here? You should see two reasons. Well, it kind of goes hand in hand, but there's basically a big thing going on here that's pretty obvious. And the dot, dot, dot means there's a bunch of things in between. But you should see something that definitely indicates to you that the AUC is not perfect here. Yeah, there's a high up false positive, boom, right here. So that no class has a way higher probability. Yeah, exactly. Oh, amazing answer, David, because this is a true positive down here and it's at the very bottom. And that's why I put it there. That's not a good thing. So we have two vectors. And when you think about when we're talking about vectors in R, we're just talking about concatenating. So when we make these, we'll just do like actual, and then we'll left arrow into it, a concatenated vector. So we should kind of think about these things as we hear the problem and be like, okay, we're going to store into this a concatenated vector. Your function will simultaneously consider each pair of individuals, with one being from the yes, another being from the no class, and find the fraction of pairs with scores of probability ranked. This fraction gives a good approximation to the AUC. As with always, it's best to build this up in pieces. Let's work with the following: actual and predicted. Okay, cool. So here we are. And so everyone should have this. I'm not working with the solutions. Good. Just making sure. Okay. So, oh, good. It does print it. Okay. So when you look at this code right here, we're storing into an actual, and this is just appending onto it. So we're setting the randomness to 474, because it's class we're in. Then we are storing into actual. We're taking a sample, which we're storing this as a factor, and we're repeating yes and no 8 times. So this right here is what we're sampling from. Everyone will get the same randomness though. And so if you were to do this repeatedly, oh, that's just because it's factor that. If we were to do this without the set seed, we'd get different samples though. So if you notice, my sample changes right now. If you look, it's no, no, yes, yada, yada. And then it's yes, yes, no. So it's not always going to have 2 in a row. But this is just randomness right here. But with the set seed, it's still randomness, but it's controlled randomness. So now whenever you run these codes, you will get no, yes, no. So it doesn't matter. Everyone should be getting this. Can I confirm that everyone's getting no, yes, no, yes, 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 no, yes? Is everyone getting that right there? Because that'll say that we're all using the same version of R. And then we have, next we have the predicted probabilities. And if you notice right here, the predicted probabilities are out of 100. Oh, you guys are not getting that? Uh-oh. What version of, are you guys using 3.6.2? It might be you guys are using 3.6.2. You have no, yes, yes. No, but don't update. You're supposed to, that's the thing. Because I'd put it this way, I did not expect to use this computer this semester for teaching R. So we have you guys use the same version of R. It's like I need to downgrade. So don't update right now. That's and if you see weird things on assignments, always talk to me. I tell you guys what. Someone copy paste their vector into here. Yeah, no, keep to 3.6.2. Don't update. Do not update. Do not update. Okay, do this. Tell me your actual. Someone put in the chat their actual vector and I'll copy paste it. So you can just put it and I'll put the commas between. So copy paste your actual and copy paste your predicted. I am going to use a trick that you guys taught me with Command-Shift-C, block comment. So copy paste your actual and copy paste your predicted, and I'll use those. And I might try to get 3.6.2 on here. So someone in the chat will put, just highlight your vector right here, whatever it is, and I'll fix it up when it gets in here. Let's see, who has it for a million, not a million, 100,000 points. 1 out of a million, first person. Oh wait, there we go, Jessica got it, okay. 1 out of another person, big points today. Who's gonna get the predicteds? So put the predicteds in the chat. There, oh, wait, I hit copy. Hit the wrong thing. And it looks like people are saying the same thing right here, so that's good. I should be able to copy this. Copy, copy, copy. There we go, we got it. Okay, so let's get this fixed now. So I'm gonna fix this up while we do this. Probably easiest. My mouse is so far over. If I knew a quick way to, there's a quick way to do, and I'm gonna use the trick here where I do this, makes it look nicer. You can always, oops, computer. I know I don't have commas right now, someone might be saying that in the chat, I'm gonna do the commas afterwards. I'm just doing all the, since I have to move my hands so much, I'm just doing all the quotes right now, and then I'm gonna do the commas. And then we'll do the other one. The other one will be easier since it's strictly numeric. But these are all the yeses and nos. Now I just got to put commas between these. Always be like, why are there red lines underneath my code? Might have been easier if I typed it. And that should do it. Okay, cool. Now we need the predicteds. Can't copy paste when using. Nice. That's cool. Like that you're watching it here. And oh wait, John, is my predicted the same as your guys? I think my predicted's the same. That's weird that my other one's not. My predicteds are the same. So if it looks like they are, I mean, I'm looking at the screen right here, and looks like it. Yep. Oh, well, what the heck is going on? Why is everyone else getting a different actual? Thank you, R version 3.6.3. That's weird. I don't understand things sometimes. You would think setseed would give you the same thing, but R was like, no, we're going to update the randomness. Why'd you do that, R? It's better randomness, more random randomness. Okay, make a data frame called values, whose first column contains the elements of actual and whose second column contains the predicted. The column should be named actual and predicted respectively. Include the results ahead of it. Okay, this is, I always love this because this is something I asked Dr. Petrie of. I said, how do you make a data frame to Dr. Petrie? And he told me, he said, you write data.frame. You write it properly, though. So it's one of the first questions I remember asking Dr. Petrie with how to code in R, how do you make a data frame? So when you make a data frame right here, just remember we're storing it into something. That's what the left arrow means. When you make a data frame, everything you're inputting it into this is a vector. So literally, let me show you by going over here to Absum. You're literally going right here and inputting a vector, as in like, here's your first vector, here's your second vector. So each argument that I'm about to put in is a vector. Does everyone understand that? I'm gonna put in each vector. And it should be pretty quick. Because I think we can just do, if we can spell, we should, because it should call them that. There we go. 6 by default anyways, but there we go right there. Did it. Remember, each argument is a vector. Just when you understand how the code works, it's just knowing how to talk to the computer. It's just like, hey, put these into a data frame, make this the first vector, make this the second vector. And I like to hit enter after my code. That way it's got spaces and looks nice. But does everyone understand how the data frame function works? It's a very valuable one. Just turns it into a data frame, and each argument you put in, at least the way I use it, every one of them, because there might be advanced things I don't use in it, but every time I use it, I just think the first vector, and the vectors are now like put into columns. So the first column, the second column, the third column, and you just do vector 1, vector 2, vector 3, and they're all separated by commas. So boom, we got that right there. And we've confirmed it. Make 2 new data frames, 2 new ones. Oh my gosh. Which contain the rows in values corresponding to yes, which contain the role. Okay, so we got a subset here. So when you think about this, and you can use a which, probably won't use a which, include the output of the two. Okay, so we need to call this yes, and we need to call this no. If you look, it's only got 3, so, or 6. Oh no, I only did head 6, so there we go. Okay, let's check this out. You ready? Does anyone have any idea how to use subset? I want you to type in the chat. Talk to me here. How do we use subset? It's a very common function that I think a lot of people forget how to use. Let's not store it yet. Let's just take a look at it. You have to the first thing in subset, when it gives you x is start the subset function. David, 10,000 points, you're right. We do start with the subset function. And we need to put in what do we want to subset. So we want a subset, and I think we called it actual capsule. No, we didn't call it actual. Values, that's what we called it. I wish it's over there on the side. I can see it now. We called it values. So the first thing you have to put in is what do you want to subset? Always talk about this as, I always say, read your code as sentences. So subset the values data frame for me. Now you have to tell it how to subset it. The next thing after the comma is all the conditions. Now remember, this is where you can start putting in your ands and your ors. So you can start putting in, that's not an and, there's an and. You can put in your ends and your ors. So you can do all these things right here. You can do the contained in, all these things. That's not how we write code though. But this is where all your conditions go. So let's put conditions right here. Let's make it very clear to people. What are you subsetting? And then these are the conditions. So this is how the subset function works. The first thing is what are you subsetting, and the next thing is all your conditions, and each argument is separated by, for 100,000 points, each argument is separated by a what? For 100,000 points, each argument is separated by a what? First person in the chat, each argument is separated by a what? For 100,000 points. John got it, and also David. John and David right there listening close got it. So each argument is separated by a comma. We should know that instantaneously. So very important. So what am I subsetting? Values. How am I subsetting it? So let's see here. We want to do actual equals yes. There we go. Always run it. Make sure it works. Ooh, that does not look right. Oh my gosh. 10,000 points. Ugh, brain's not on. Always look at it. That was a mistake, not on purpose. You got it, John. There we go. If you know, just so you know, I went to it and was ready to do it. So John, you are right. I didn't do logical equals. I did set equals. I did like a left arrow equals. So yep, I did not do logical check equals. So because remember, I always say logical equals in class. Logical equals is equals equals. So you're seeing if it's logically equal to that. We basically have it right now. There's that. And there's that. And copy paste is your best friend because you've got autocomplete as your best friend and copy paste. Two amazing friends for you right there. There we go. Oh, and then is this called capital? Oh, capital no. And we could do remove no. That just removes something right there. RM is remove. Kind of like classic like DOS commands right there. There we go. We are good to go. If you notice, it has the original row numbers. No big deal. But that's what these are on the side right here. But now we've made a data frame of no, and we've made a data frame of yes. Consider the scores in the first row of yes by taking the mean of the logical condition. Find the fraction of scores in no that are smaller than the score and left arrow it into a variable called properly correct rank. So percent correct rank. Print this contents of percent correct rank to the screen. Okay. Here's where it gets fun. So consider the score in the first row of yes. Okay, so let's look at that. Here's the score in the first row of yes. By taking the mean of a logical condition, find the fraction of scores in no that are smaller than this score. Okay, so first thing you want to do, break it down in parts. How are we going to find the first thing in yes? I want to see it in the chat. Like break this to parts. How are we going to find the first thing in the yes data frame? The first thing in the yes data frame. There's quite a lot of ways to do this, but it says consider the score. You could use head. You could Yeah, maybe here we'll do it that way. So we could do, yeah, that'll do it. Head, yes, comma 1. And I wonder, because, yeah, I think I'm going to do it. So, David, you're really close right there. And then this. So we just want. See, even now I'm like, I don't want to do it this way. So probably I would do, yes, $, predicted. That's what I would do. So this is the way I would do it right here, because I just want that score of it. Because we already know it's a yes. We already know everything in there is a yes. So I just want that score of it. Does that make sense? I just want that, and that's probably the quickest way to get to it is like the first thing in the yes data frame. So there's a lot of ways to do it. So David, remember, it's two-dimensional. David and Jessica and John, 10,000 points for those answers right there. Remember, it's two-dimensional, but I went to the vector inside of it. So if you do yes $1, you'll get a dimension error, or it does that. It gives you the first column, and that gives you the second column. Didn't know that. I just never do my coding that way. So you try something. So, but that gives us the columns. It doesn't do like a two-dimensional thing. So by doing this, I'm just going to the vector. You could also do the following. We just want row 1, column 2. So that gives us the same thing as yes, $, predicted, position 1. So if you notice, those are the same things. So a lot of ways, excuse me, guys. A lot of ways to get the same code right here. And yes, just a lot of ways to get the same code. Good stuff. Okay, so we have the first element. I'm going to use the second way right here. And now we want to compare it. So we're not going to store it yet. We're just going to do a comparison. We want to see the percent of time this is bigger than the nose. So we need to look at the percent of time. So let's do greater than, and just say greater than or equal to. By taking the mean of a logical function to find the fraction of scores in no that are smaller. Okay. So, yep. So this would be it. And no $ predicted, if we spell no properly. And we go right there. And we get this. Ooh. Well, that's interesting. So, and we want to find the ones that are smaller. So if we want to find the ones that are smaller, so, let me think. I'm doing this in reverse right now. Because find the fraction no's that are smaller. So this would be no's that are smaller because no is less than, please correct me if I'm wrong, but this is ranked correctly right here, and it makes sense because the yes should be higher than the no's. Let's confirm this. Let's look at the probabilities on the no's. And all the probabilities are smaller. So if we notice all the probabilities are smaller, we should be getting trues because our probability was this. So it does make sense that all of these are true. All these probabilities here are smaller, so all of these are true. And now what do? I think it says it. I won't ask because it says it. One of my favorite tricks in R is you can highlight the code. You can do that. And you can go right here. You can type mean, and we should get 1. I say it as it appears. And then we go right here and we do this. Not that. We do that. There we go. So that has now stored the percent of time that one was ranked correctly. So someone interpret this right here. Like, what does this 1 mean? What does this 1 mean? What does this 1 mean for this right here? The first row, what does that 1 mean right there? 100% of the time what? What does the 1 mean right here? This will hopefully have everyone understand AUC better. This 1 means that first row received a higher, who knows in chat? I'll say it once someone says it. The first row received a higher probability, what percent of the time, than all the whats? Let's see if someone says in chat. Kind of say the whole thing. Think about the whole thing. The first row received a higher, and then the whole thing. Higher probability, yeah, the first row received, was always ranked higher than the nose. Jessica and David and John, great answers. Received a higher probability 100% than the nose, yeah. So the first row, 100% of the time is properly ranked. So that's what, because it should receive a higher probability because it's actually yes. Remember, it's actually yes. So the first row received a higher probability 100% of the time, which is really awesome. That's what we want to see right here. the first row received a higher probability 100% of the time. I'm looking at the answers right here. And I'm like, okay. They have different probabilities. Let me look at their no's. Where are the no's at? 147. If you're doing this along with me, because I'm looking at the answers right now too. If you're doing this along with me, what is your no probability? Like the answers say 137, and that's a little bit different from mine, because is everyone getting the same answers I'm getting? If we get different answers, I'll just correct it. But this is correct. Like this is the correct way of doing it. It's just randomness will change things. So we'll see if everyone else in the chat's saying the same thing. But if you guys told me the vector correctly, we should. So yeah, I think just the ordering. Yeah. So I think we'll have to see what happens. If something weird happens, we'll just correct it. But we are doing this correctly because I remember doing this previous semester. I was like, I don't remember getting 1. I remember getting it's 0.87 up here. Okay, so let's go on. Let's continue on. And now we just have to do where we loop it. Now write a loop that does this for each score in yes. Well, okay, so what did we write right here? You guys should know what we just wrote. What did we just write? What did we just write? We just wrote the what. You should say it in chat. We just wrote our what. We just wrote our what. You should know it. Skeleton. We just wrote the skeleton. The skeleton is the code that will loop, and we'll do it each time. So all we have to do is just do this for each one. So you just have to think the skeleton we've got here. Now, the reason we don't have to initialize this is that it's already initialized, and by initialize, I mean create. We usually use a placeholder of this, and this is what will change. So the variable is I, and then it'll go through 1 length of yes, and that should do it. That did it. I'll talk about this more in a moment. Ooh, uh-oh. Yes should have more than that. 1 through length of yes. Let me look at this. Make sure that's 1 through length. Wait. Did I mess it up? Oh, haha. See? That's why you always look at it. There we go. Okay. Length of a data frame is like how long the data frame is. We want to do number of rows. So you can do length of a vector. I thought about that. I was like, should I do length of a vector? But length of a data frame is the rows, the columns in a data frame. So I said 1 through 2. And now we should have it. We'll talk about what this code does. And there we go. There's the vector. That's not the same answer we usually get. I was like, this looks so... All the no's have lower probabilities. It's an answer. We actually got a good AUC. So we're pretty much there. But let's talk about what this does now. So what this does is it goes in and it looks at the first time it does this, it's going to put 1 here and 1 here. Did we already do this a moment ago? Yes or no? This looks at the first row and compares it to all the no's and then stores yes. This is exactly what we just did. So then the only thing that changes is now it goes in here and it does this. And now this looks at the second row in yes and compares it to all the no's and figures out what percent of the time. So can anyone take a guess from me what row in yes had the lowest probability? What row in yes probably had the lowest probability? What row in yes had the lowest probability? Row 3. And what does this 3 mean right? What does this mean right here? What does this mean right here? What does that value mean right there? Row 3. Row 3 was properly ranked 62.5% of the time, or received a higher probability than the no classes 62.5% of the time. So I think there's like 8. So I think like 5 out of 8 times the row 3 received a higher probability than the no classes. Row 5 has a 0 though. Oh my gosh. 100,000 points, David. David, great job. I didn't see that either. I kept seeing all those 1.00s. So David and John, 100,000 each. You guys noticed that. That means that one is very improperly ranked. And John, yeah, thank you guys so much. I didn't see that. And you're 100% right. So easy to miss that. And look at that right there. That's the one you're talking about. Now, these are the original row numbers on the far side. Don't be tricked by this. This is the third right here. And this is the fifth. So teamwork, exactly. That is the one you're seeing right there. And what does the 0 represent right here? What does the 0? I'll be right back. Put it in the chat. I'll be right back. Hi-oh. So higher probability yes than the no 0% time. Yep. That row right there was ranked properly 0% of the time. It received a higher probability than 0% of the no class. So does that make sense right there? It means that that row in the yeses received a higher probability than the no's 0% of the time. Does that make sense to everybody? What this value right here of properly ranked means? This row right here, this one specifically relates to this, and it received a higher probability than the no's 0% of the time. Like when we looked at all the no's, we're like, okay, let's compare it to the no's. It was higher than the no class 0% of the time, which means it's totally improperly ranked. So that's one, like I did my example earlier. You know, I did this one right here. That is, I know it's a different probability down here, but it's this one down here. Now, these are not the probabilities right here that we're doing when we're finding the P correct. These are the actual probabilities of them. Does this make a little more sense to everybody? Like, are you following along? Like, we're talking about the percent of time it's properly ranked, and because there's a lot of percentages being thrown around right now. But this one right here was ranked properly 0% of the time. Like, it received a higher probability than the no classes 0% of the time. So that is very, very bad. That's horrible. I think we're basically done, because now left arrow into AUC, the average of the values in P correct rank. So print the content screen, verify that it's equal to this. It's not going to equal that. So tell me what you guys get. You'll get what I get, and then I'm going to change the vector because I'm going to take from the answer sheet, and so we'll do that. Because I was worried about, like, I was worried when I did this, like, my version of R. I realized it when I was like, I bet it's going to be wrong. So, okay. So let's do this right here. We just do mean of the P dot correct, and it's not that. Okay. So I'm going to grab the correct vector because the yeses and the nos are changing. And here's the vector. And I'll put it in chat so anyone watching the video can grab this vector and do it. So all we're doing is just changing the vector. Is there a quick way to put... I will throw 1,000,000 points if someone knows a quick way to put commas. What I should do... There is a quick way to select stuff like that. See, I do know some stuff. And then we can do this. And then we can go here. And then this. And then here. And this. And then just gotta remember, so we're just having fun. That does work, but I don't like the way that looks. And I've learned so many shortcuts in the years of doing computers, and then I forget them because I'll teach myself them, but then I was like, I think I know a shortcut for this. And each time I do it, it doesn't feel natural, so I'm like, what is it again? So, but I wish there was a way. Maybe someone's saying, paste in Excel, import as data set. Yeah, you could probably do that. You know, we always... Like, we talk bad about Excel, or at least I do. I don't know about you. Like, I never talk bad about Excel. But Excel is very useful. Even if you have skills in R, it never hurts to have Excel skills. Never ever hurts to have Excel skills. Because it's ubiquitous, it's everywhere, And yeah, it's a good program. I like R better, but you know. Okay, so now that we've got this right here, let's go down here. Let's go down to the following. And cool. Let's run everything above. We ran everything above, and then we run this, and it says a different answer. What is going on? Does this give the same? Let me look at the digits on this. Let me see if the digits are the same. That's the only other place it could be different. Let me look at the values in the random created. So this now has this right here. We blocked that out. The actual should be saved as this. We did put these into a data frame. See, this is now a no. Well, see, this one's now a no, so that drastically changes it. So that'll change the way the answer goes. Let me look at the values. 33, 68, 49, 29, 38. These look the same. 92, 41, 52. Look what does the answer key say? Let me look at the vector here. So if this was made in 2019, it could have been even weirder version of R. Yeah, I know, right? That's the issue. Is like we never thought things like this would occur, but they just start to occur, and I'm sorry. Oh, John, look. I bet this is it. $10. Someone's gonna want the $10 now if I do this. I bet that's it because I was playing around with my code, and now I bet that's it. Bet it's not. Try it again. Run all code above. Run current code. Okay, it says that. Okay, so let's see here. I know I thought that. I was like, oh, of course it's going to be this. It's weird that didn't change. So let me look at my p-correct vector because I can get that on screen. Wait a minute. This is looking... This is 100% correct right here. So how can this be correct? And then the next code here, because this is just... Oh my gosh, I will show you this. I will show you the key. We didn't just... I'm copy pasting from it. You ready for this? Guess what the key says right here. Oh my gosh. We have the right answer now. So there it is. We did it. We got it. So everything is correct right now. Code's working correctly. I was like, I don't see any errors. But, and funny enough, for some reason it still worked even when we had that weird error in there. So the key doesn't lie. Well, the help thing lies. Sorry about that. So the whole point of all this, let's take this. Sorry about this. They are the insanity checks right there. So the key doesn't lie. It doesn't lie. It just, I should look at it. I should look at it more often. So, okay, so now that we've written this function, the whole point of this is to run this right here. So we're going to turn this into a function. Okay, so test your function on vectors, scores of individuals, defined by the class, And so we have to take this and turn this into a function right here. So let's think about how this works. Okay, so the first thing we want to do, we want to take and store in, like we've been doing, it's literally just taking all your code you've written and grabbing this and bringing it down here. I hate that it does this little pause on me. But you go right here and you put this right here. So let's take a look. And someone's going to put in, let's look at the first thing. What's going to happen right now when someone initiates this function? When someone initiates this function, they are going to put in what? They're going to put in their actual, and they're going to put in their predicteds. And then it's going to do what on line 90? It's going to do what on line 90, which is what we were doing just a moment ago. On line 90, it's going to turn them into a, who knows? I'll grab the next one. On line 90, it's going to turn them into a data set. You're right. And then what was the next thing we did? All we're doing is copy pasting our code. Now we're going to subset. I'm going to hit the microphone. We're going to subset these right here. If you notice, we're just copy pasting the code. So now we're going to subset. And we have this right here. And there we go right there. So now we're going to subset the yeses and subset the nos. That's all we're doing. And then all we're going to do now is we're going to take this right here. Now, what I want everyone to think of, here's a big question, because we're just 2 lines of code away. For 100,000 points, can anyone tell me what I need on line 93 or line 96? Oh, yes, Christian, you got it. Christian already knows what to do. Return, and then we could do this. Well, we could probably do this. Well, let me do it the other way. We did this also, remember? There we go, and then who knows? What's the other thing missing? I'm still missing one other thing right here. I'll give you a hint. Deals with that. So what else are we missing? We're missing one other thing. We didn't need it before. And truthfully, this might run, but if we send someone the function, it might not run because they wouldn't have the same global environment we do. So this probably would run right now because of our global environment. But if we clear the global environment, it won't run. So, because you can see it in the go. Declare, yep, exactly, initiate the vector. And what I'm saying is right now it's in the global environment, so I think it will, because if a function's running, it'll look to function world first, and then it'll look to global environment. So if it can't find it in the function world, it'll be like, maybe I should look in the global environment. So it'll do that if it can't find it. So we need to declare this, so we just go here to p.correct, and it's cool because we already have it there, so it does it. We don't do capital. We run this. Run this, run this, run this, run this, run this. Pairwise. Oh no! There's the... What is going on right here? Did I do an error? Let's see. Let me try the answer key one. That should do it. And this is knitted, so where does anyone see an error in my code? Because I don't see it right now. P-correct rank, take the mean of P-correct rank. This is NaNA. So return AUC. So the first thing, let's see. Let's do it the easy way for now, and then let's do it the hard way. So it looks almost identical. Oh, okay, there is an error in my code. Okay, where's the error in my code? Let's not cheat too much. Let's find out. So we're storing the values. We did it all. Oh, I think I see it. I see it. Who sees it? The third argument of the function. I think I see it. I think I see what it is. I have a different idea than John right now. I have a different idea than John. I think the error starts on line 94. Pretty sure that's it. Who sees it for 1,000,000 points? And I'm giving it away. I think the error needs to, well, it's basically, you'll see it. It's kind of, funny enough, I somehow clicked on it while doing it. But I think I see what the error is. It's pretty obvious now that I look at it and I'm like, okay. And you'll be like, did you really see it? And I'll be like, yeah, it's highlighted right now. The error is currently highlighted and begins on line 94. Who knows what I'm talking about? You can see what's on line 94. Who knows what the error is? Oh, 1,000,000 points on the line. Yes, that is what it is. It's that's in the wrong spot. So didn't close. David and John, you got it. We're giving out huge points for the activity. Thank you guys for being here. This is the practice you need. It's like you think you do everything right, but you make one mistake. You don't put the close to the for loop right there, and that should go away. It went away. And then we run this, we run this, we run this, run this, run this, and let's take a look. Okay, what's going on here? It should do it. What happened? John, did you also see something else? What other error did you see, John? Because it's not like in my code today. And where? This is the correct. So there's the close to the for loop. There is the P correct. There's the AUC. Oh. It's the default. I think John was saying that too. Is that going to be it? Let's find out. Well, that's a totally different AUC. The third argument is declared the LOI. The third argument is declared, yeah, right here, it's declared as positive. And so let me look at this again. Oops. Let's see here. Positive. Oh. It's so obvious now. It's so obvious. And it's so obvious why it's basically 50% now. Another 1,000,000 points. It's so obvious. The error's on line 92. So many small errors. So many small errors. Think about what my subsets are doing right now. And right now they're doing something just not right. My subsets, especially line 92, is just doing something ridiculous. I'm purposely putting these errors in to test you guys. This is how you have to think about code. You have to be like, it's declaring the same thing. Yep. This is making the same subset as this right here. And so what do we need to do? We don't want the positives. We want the not positives. Okay, let's hold our breath. Got it. Yeah. Yep, there we go, John. Nice answers. This is what you got to do with code. You got to be like, okay, what's stuck? You have to test your brain. You got to be like, okay, it's early in the morning. It's not so early anymore. But you have to be like, I got to get my brain going. Got to look at this code. Got to figure out what's going on. And yeah, pretty tricky right there. So once again, little error in a function. You know, you can know these things conceptually backwards and forwards. But then you make one error in your function and it's wrong. So the best thing to do is to make sure your function works and to write your code slowly. It's so easy to make one little error. I think we had 2 errors. We had the for loop not closing. I saw that one pretty quickly. And then the way this function was declared up here with what positive is, and I don't like it being, I like my yeses in quotes like that. So let's hope I didn't break anything now because I think it is written like that. And then I'll just rerun everything. If you notice, what do we get? We can actually run the AUC function. Let's take a look right here. This is the ROC, which is an AUC function right here, which when you look at what it has right here, we want the wine quality. And so this right here is just the high-low quality. We've got the predicted qualities of the wine, and then the levels are low and high. And then that just tells it what the 2 levels are because that's what the vector has. We could have probably done it another way. Oh, go all the way back up here. Probably, I bet levels, the easiest way of doing this, and I wonder if this will change the AUC, I'm interested now, is probably going to go here and go, let's try that, and it does the same thing. It's probably the way I'd do it right there. If you just think about it, why type in the levels when you can make an error if you can just go here and tell it the levels like this? So you can just tell it the levels by saying, here's the levels, like, so levels equals this. And let's see if this is the default for it. Because if it is the default, nope, it's not the default, not the next argument. Remember, arguments have defaults. So the first thing as a default in this argument is, what are you predicting? You're predicting wine quality, and then the predicted values of it. And then levels looks to be an optional argument. Let's remove the optional argument, see what happens. Still does it. So, and does the output look any different with, it just looks, the code's longer. It just shows the call. So always be working with these things. Setting direction controls greater than cases. Don't know about that. So always kind of look at your code, see what it's doing, play around with it. Always a fun thing to do. If you notice our code right here, the whole reason we wrote our code, so we just wrote a code inside of R. In part E, I got it an average of 0.8125, but I got the same thing for part F. Boom. And actually, you know what? That's the thing that matters, is because the top part is just an example. So the top part is just you kind of working through example and seeing how it works. So you don't have to get the same thing. I think, Jessica, because I have the other vector. Do this, Jessica. Jessica, 100,000 points. Thank you for the answer right there. Copy, paste this. Copy, paste that right there into your code, and instead of use that as your actual and then run all your code again, and you'll get the same thing, I believe. So Jessica, thank you so much and great work. Thank you for everyone following along right here. And let's continue on. So we've got all of our code. I think we entered that all in, such a short thing. And now we're down to the last part right here. last part of the assignment. Okay. This part is from the lecture slides with minor changes. Please read the slides for background introduction and follow the instructions here to answer the questions. First, we load the data sets. Okay. Load the PIMA. I think this is a body weight data set. So, or is it diabetes data set? Oops. There we go. I should just use, you know what? I'll show you guys a really cool thing. Do I have it on here? I think I should. Yep. This is a Hadley Wickham package. Really great package. When you do Glimpse, it shows you, and it is the pregnancy, body fat, BMI, all this stuff right here. But the function Glimpse shows you the start of a data frame, and it augments this to your screen. So great job, Jessica. So Glimpse is a really awesome function that just shows you what's in a data frame, gives you the variable type, but really great way to just look at it. So if you're looking for a really great thing, install dplyr. It has Glimpse, and dplyr also has a lot of really good stuff. Great package to learn, DataCamp, DataCamp, DataCamp. So using 80% of the data for modeling and 20% for holdout, create a training model and holdout model. Holdout model. There we go. Okay, so let's do this. So how do we create training and holdouts? We use, we go right here and we sample. So we need to sample and 1 through the number of rows in PIMA. And if you notice, that's just a sample. And then we need to do the size of it. And then, cool. Let's look at what the arguments I've written right here are. We have right here that we're taking a sample from these numbers. So this just tells us the numbers we're taking a sample from. So why am I choosing these numbers? This is 1 through how many rows there are in the data frame. And then what does the second argument tell us? For 100,000 points, who in the chat can tell us, what does argument 2 tell us? So let's do this. There we go. Yep, 80% of them. So then this right here is how how many do we sample right there? So the first argument is what are we sampling? The second one is how many do we sample? So when we look at this right here, we go back in time and we see this, that I can't do Command Y on here, Control Y. There's no command on a keyboard on this one. So there we go. And now we get this and we're going to set the seed. So we'll get the same thing. Let's call this train.rows. Dr. Petrie taught me to call it that. There we go. Now we're going to go here and we're going to create a train data frame. The train data frame will be PIMA, and we're going to go train.rows right here. I'm going to put one error in my code on purpose. There's a common error I see, so I'm showing it to you right now. We thought about it earlier, but I need someone to tell me what error do I have for 100,000 points. This is a common error I often see, so I did it on purpose. So I didn't run my code because it's not correct right now. What error does Brian have right now? He has a very common error that we often see. What error do we have? 100,000, David, right there, taking a stab at it. No, or maybe there is, but no, good guess. It's a very common error. I see it all the time. Oh my gosh, you are right, David. 1,000,000 points, David. Why not? You are correct. Wow. David, you are correct. David, you are correct. I'm sorry. I just didn't. My brain broke. Wow. I would make. David, nice job. You are correct. I was like, minus. I was like, what are you talking about? Yes. But there's still the other error that I see. I was so intent on making this error, I put in another error by mistake. So you are correct. Always look at what you create. I always do that. Don't worry. Whenever I create stuff, I look at it. It is correct that it is columns, so you are correct. That is basically it. And how do we fix that? I guess you're right. It would only do the columns. You're right. So we saw that earlier. That's going to like try to take columns. So now it should work. And let's take a look. We don't have to really, we could click on the data frames, but if you notice, this has 79 observations, 8 columns, 313, 8. So both David and John, 1,000,000 points, and Jessica earlier, 1,000,000 points. Great job. I like that you guys are here following along. You got to practice. You just got to, sitting down and coding and talking about it is the best way to do it. So thank you for being here and just trying to do the coding. It's the way to do it. Using threefold cross-validation, report the accuracy of the cross-validation on the variable dataset diabetes. So we have to think about what k-fold cross-validation is right here. So when we do this right here, and we're going to double check. So we got some double checks in here. So well, that's not the, well, we can make sure we're getting the same thing that the key has. Let's take a look. So we should have, yep, same thing. And then that's the training. And we should get 34.1. Yep. Cool. Okay. So here's where we get into some big stuff. And I'm going to copy the code here so everyone can see exactly what we have. Okay. Everything's right here, but let's just put the whole thing in. Okay. This is so important. And I hope everyone watches this because you have to understand this code. You have to know what's going on with this. Let's break down here what's going on. Each line of code. Line 141 is setting the randomness. Line 142 is figuring out how we are setting up our fit control. Our fit control is how the model is fit, and we are going to fit it basically by testing it out on a validation. So remember, how do we create our model? From the training data. How do we select our model? By the validation. How do we know our model works? The holdout. It sounds crazy. It's a very complex process that works really well. So people, came up with this process. It's more than just like getting data, making a model. It's getting data, making a model, testing it out, and then putting it to the final test on the holdout. So what does this mean right here? 100,000 points in the chat. What does CV mean? Now there's other methods you can use. There's boot and I'm trying to think of other ones, but you can bootstrap it. That's the other probably most common method. But what does CV mean? That literally is the what? Cross-validation. You guys are right. It's the k-fold cross-validation. We talked about that yesterday in class, but this is where you're telling it to use k-fold cross-validation. This is the number of folds. Now there's repeated k-fold cross-validation. So you can do method repeated k-fold cross-validation. So you can look right here. If we go here to question mark train control, and there we go, and we go here, and we can get, it's over here on the side. But if you look at the different methods, I'll bring it up higher here. There's right there. We'll go to methods. So here's all the different methods. You've got boot 6 through 3. You've got repeated CV. I don't know what low CV is. I think they've added things. So there's more. But you've got so many different methods. Optimize boot? No idea. So there's tons and tons of methods. There's so many ways to do things in statistics. So you might learn different things, but we're just using cross-validation here. Repeated cross-validation is not bad either. So I'd probably use repeated. We'll talk more about that later. Not today, though. So repeated cross-validation is just where you repeat the k-fold cross-validation process. So we have class probs equals true, and this is huge. Why do we have class probs equals true? I don't think I've told you guys this yet. We have class probs equals true here because this is a categorical variable. You have to have class probs equals true for categorical variables because you're predicting the probability of classes. So when it's categorical, you have to have this. So let's look right here. Does everyone remember from 320 y tilde x comma data equals? Classic right there, y tilde x comma data equals. We basically have the same thing right here, but now you have two more arguments. You have y tilde x comma data equals comma method comma your train control equals fit control. So if you notice, we set this up outside of this. You could kind of take this whole thing and put it inside of there, but that would be a lot of work to have this inside of here. So we usually just set it up outside and we put the TR control, which stands for train control. Here's the thing people often forget. This has a capital C, and this has a lowercase. It's very easy to make a mistake while typing that. I see it all the time. People say their code doesn't work, and it's so hard to see because that's what the code looks like. So it's very hard to tell because there's a lowercase c right there, and it's just the smallest of errors that whole code doesn't work. Or they do something right here where it looks like that, and that makes the error too. So that'll still not run. So very, very small errors, lowercase capital letters will do it. So now we have here that we are making a model predicting if someone has diabetes. We are using all the variables. That's what the dot means. And then we are going to use the training data. This is so key. We make our model from the trained data. we then get an estimate of how it'll work using the k-fold cross-validation process. So let's go ahead and see this right here. The method is GLM. That stands for Generalized Linear Model. We're doing that because this is a logistic regression. And then we're going to use the fit control we set up previously. And boom, we got it. There's our model. Let's take a look at the summary of the model. There's the estimates. What's the most important thing in predicting if somebody has diabetes? What is kind of the most... What variable brings with it the most kind of valuable information that the other variables are not accounting for in this model? Any ideas? Any idea what variable is bringing with it the most valuable information for diabetes? Any idea what variables bring with the most kind of unique, valuable information that the other variables are not bringing with it? It is glucose, which makes sense. Glucose is definitely, a variable. You have a different answer than the ones that you have for mean, and same with holdout. Oh no, is it? I've got the same answer as the key. Do this, David. Here's what I want you to do, David. Go back up here. Am I on the bottom screen? Good. And go back up to here, or no, do this. Yeah, I'm about to do it. Run the chunk as a whole. Run the chunk as a whole. So run the whole chunk as is, because maybe you didn't run the set seed right after, but tell me if you get the same answers if you run the chunk. So run the chunk just as a chunk and tell me if you get the same answers. So just click the chunk and see if that does it. I'm going to cross my fingers because I'm hoping that maybe you did it in parts, and if you run the chunk as a whole, it'll do it all in order. And so that, oh no, oh my seed is 7. Oh my gosh. And then how did it is 747. Did I do that to it? It is 747. Yeah, it's that way in the key too. Do you guys have 474? What do I do this? This will totally change it now. Yeah, it totally changes it. 2 seconds. Okay. So, no big deal. Here, I'll show the answers here. So I'll check the answer key too. That's weird. I think it's because you guys are using 3.6.2. 3.544 on the holdout mean. And, oh man. We'll be looking into this and we'll make sure. So we'll go ahead and we'll answer the whole quiz after this to make sure everyone gets the same answers. So sorry for all the craziness on the answers, but remember the theory is always way more important than the answers. So we'll make sure everyone gets the right answers for the quiz, and it's more important we understand what the code is doing. Don't worry just because of randomness. So Quinlan, so good to see everyone here and so good everyone's working along. But we want to make sure you understand the concepts better. So I'll be looking through and checking these. Sorry about that. R is weird. You guys are awesome. You guys keep me nice and positive. I like it. So I'm really happy text messages keep me positive too. So, so here we are right here. And what do we have? I'm just sorry. We have, we have using k-fold report the accuracy of the cross-validation reports, predict the probability, my brain broke. Using the threefold, please, that's very nice. Please report the accuracy of diabetes. And so let's go ahead and do that right here. So if we want to get the accuracy, please report the accuracy, we should be able to get it because we can go in here and let's go to there. Yeah. Let's look at model. What's interesting is the model is actually a list. So the model is actually a list of everything the model reports. We talked about kappa a little bit. We did yesterday. Not my favorite thing, but we've got the accuracy of the model. and we want to report, I think it just said report the accuracy. You have to do something different to get the AUC out of the model, so the AUC is not as easily obtained. So let's take a look right here. Yep, there it is. There's one last argument we need to get, so I'll just take it as is. Here's some of the most confusing things. I'm glad, because this basically covers everything we need to know. All we're really going to change, it's already here. Here's the biggest thing. Okay, be taking huge notes on this. The way we set this up prior, the way this is set up right here, will get you what? Look at my bottom of the code. When you get your model results, this will get you what? When you get your model results, this will mainly get you what? This is set up right now to report the what. We'll put a hashtag on it. Put a hashtag on your code too. These are huge notes for the rest of the semester. This is set up to report what? Accuracy. John, you are right. And then this one right here, boom. So what we can do is we can take, and let's just grab our model. Let's remake our model down here. And there we go. So does everyone see right here that the first one was set up to report accuracy and the second one was set up to report AUC? So please take note of this. I want you to see the small change in the code that it's only this extra argument. This extra argument changes it so that it reports ROC. That's the only change. It also reports other stuff, but, and we can take a look at that briefly if you want. But we have here ROC, and we also get the ROC standard deviation. And I want you guys to take a wild guess what models would be basically similar to like a model. If you think about this, if this is 84%, then a model with an ROC of something would be basically similar. Just round it for 100,000 points. Use the knowledge you already have of standard deviations, and a model with an ROC of about what would be basically similar. Like, let's say we have a model that does worse, but if it had about this, it'd be basically similar. Like, they're about the same. And I guess we would have to look at its thing too. But think about what I'm trying to point out right here with standard deviations and the ROC. Like, if this is our estimate of the ROC, which is just an estimate, and then we have the ROC standard deviation, yep, 79-ish. Yeah, you guys are doing it. You're doing it in your head. That's the point. That's what we want you to know and do, is to look at the standard deviation and be like, that's my uncertainty in the estimate of the ROC. Does everyone understand that this standard deviation, because we don't know the ROC is this, we're not saying like, aha, this is the ROC. This is what it must be. We're estimating how well this model will do at ranking the yeses versus the nos. Does that make sense? Like, this is an estimate. Like, we think this model probably properly ranks the yeses versus the nos about 84% of the time correctly. Like, the yes class will get a higher rank than the no class about 84% of the time. That's the strict interpretation of it. The yes class receives a higher rank than the no class about 84% of the time. When I say about 84%, well, I could be off by about 4%. Like, maybe it's about 82%, 83%, and then a model that has an ROC of about 81 or 82 or 80 or 79 would be pretty similar. And why is it pretty similar? It's within one standard deviation. And if a Stat 201 ever watches this, that's straight up Stat 201, because one standard deviation is a very small confidence interval. So we're saying they're probably pretty similar. Like, we don't really have good evidence that they're different. Also, one standard deviation would be a z-score of 1, obviously, and it would have a p-value of 0.32 on a, I'm going to literally throw a million point stats one question. Why would a two-tailed test have a p-value of 0.32 if the z-score is 1, which means that the differences between our model could occur about 32% of the time due to random chance? And why would the z-score be 0.32 on a two-tailed test? And you just have to know the empirical rule for this million points. Yep, exactly. So it's 68, 95, 99.7. It's the empirical rule all over again. And then I can tell you p-values based on the empirical rule. So it really goes back to 201 and a deep understanding of why we use these numbers. I know, nice job, John. You're doing really well. That's every one of you, but I'm really, really proud of everyone's here, like following along and doing all the work. So keep up the great work. Okay, so we're gonna plot it. Man, I love the you had your coffee. That'll do it. What kind of cream do you use, John? Do you have like a favorite cream? I like the sweet cream. I like sweet cream. I used to like hazelnut a lot, and now I don't know. I think I got burnt out on it. Sweet cream. I either get the red or the blue bottle. Like those are my two bottles I get when I buy creams. So, but you said almond milk. You know, I had some almond milk. It was really, really good. So I think there's another milk I tried it and I was like, yeah, I really like this almond milk. So, but it's vanilla almond milk. Okay. I think I've need to try that. I think I might start getting almond milk. I liked it when I tried it, and there we go. That worked. Look at a plot. I want to ggplot this. Maybe not now. Yay! Let's replot it. Let's see if it does something different. So I'm gonna change the limbs on this. I've been upping my ggplot skills. I should show you guys the code that I was trying to write on the plane. So like last time I wrote on plane, I was trying to write tic-tac-toe, and so I was like doing that, and so I was like, let me write tic-tac-toe, and yeah. So basically the same thing. Yes, it's a fantastic cereal. Everyone's like that almond milk. I think it's got it. Please report the holdout performance of the model. So that's where we're going to use the PROC. So PROC, let's go grab that PROC code right there. So the PROC code right here, confusion matrix, we'll just grab it all. I'll be doing another review here soon. So I'm like, I'm going to get some, there we go. There's the PROC. Okay, let's grab all the code right here. And then let's show it. Well, and then we'll also talk about what this code's showing here. Okay. So one moment. Everything. Okay, we will talk about this code and everything it does. And then we'll end this review session. And we'll make sure everyone gets hundreds because we like that. Okay, so let's talk about this graphic first. And let's see if it's doing a good job. How does this look? Does this look like a good ROC curve or a bad one? I'd say that's a pretty good ROC curve. If you notice, it was like 88% on the ROC curve. It can only go up. It can like go over. What's happening in this region right here where it's going over? So, and I did call these false positives right here, but you're going through your negatives basically. So you're having to go through negatives to get there. Well, no, I'd say it's fairly good. You are correct. Sorry, I asked like 3 questions, and then so the going over right here is a bad thing. Like when it goes to the right, that's bad. When it goes up, that's good. If I had to look at the way these are ranked, it looks like at the very start of it, there's a lot of yeses, and that's what this means right here. Is the kind of straight up pattern right there is that it's starting to get more and more false positives. Yes, exactly, because a true negative would be a false positive. As in, if we have to go through the true negatives, then they received a higher ranked than the positives because we're going through them. At what point do we obtain all the true positives? At what point do we obtain all the true positives? That would be this right here. This is why I'm so sad we can't do a written test, because I'd like to say put in X at the point, like put in X over the exact point where we obtain all the true positives. I don't know why the mouse jumps like that. That is so weird. It's because I'm using 3 monitors. But right here at this point is where we obtain all the true positives. When do we obtain the first false positive? Right in there. That's when we obtain the first false positive. So as we go through our data, remember, it's like we're going through the data, and we can go up. If we go up, we're hitting true positives. If we go to the right, we're hitting true negatives. Does that make sense? And eventually, where do we get to at the end of this? Just think about this. We will have gone through all the true positives and all the true negatives. So you have to keep going up and to the right. So yeah, exactly. Who feels like this makes a lot more sense after this lecture today? Like, I'm seeing it now that when you go up, you're hitting things that are actually yes. When you go to the right, you're hitting things that are no. So your goal is to hit all the yeses first. If you were to hit all the yeses, the graph would just do what? If you hit all the yeses, yes, John, that's awesome. If you hit all the yeses, if all your yeses were at the top, like if all your yeses were at the top, what would this graphic do? If all your yeses were at the top, what would this graphic do? It would just go just like that, go straight up. Yep. And then you'd have all your no's and it would go over because you'd start hitting all the no's is the way to go over. So yeah, I'm glad to hear this. We've talked about this concept like 3 times now, and believe me, when a lot of employers, they're like, well, what does AUC mean? What does this mean? They don't want to see that you just know the math behind it, because anyone, you can punch these codes in and be like, boom, 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 here's codes. And a lot of times you just type in the code and it runs, but then what does it mean? What is the point of it? Why do we use this? Awesome, Jessica. You guys are great. Love it. Love seeing that. You can always tell me it doesn't make sense. You'll be like, no, still doesn't make sense, Brian. So I'm really glad that everyone has a deep understanding of this right here. Excellent work. And so good seeing everyone tomorrow. We're not done yet, though. Let's go right here. We've got our last bit of code. We're going to store what people actually have for their diabetes value. Diabetes. Wilford Brimley. I think that's the guy who used to say that. We got the probabilities right here. What is this code doing right here? We're using the predict function right here to make predictions using our model. We're going to predict on new data, and what we're going to get out of this is probabilities. So, thank you very much. Subscribe, thumbs up. I put the monetization in, and it passed stage 2. We just have one more thing. So we might be monetized, and I'm also going to try to go to Twitch. So we'll keep our fingers crossed on Twitch and everything, but maybe this weekend or tonight, who knows, I'll be streaming on Twitch, and that'll be crazy. And I swear I want to get like a Nintendo hookup. I just play Nintendo on Twitch, so I don't know. I mean, go back old school, and I'll start playing original Mario and stuff again. I don't know. It's. I used to try to beat. And Streamlabs works better with Twitch. So, and if anyone knows a good bit about streaming, feel free to talk to me about it. I know a few. Yeah, and like we get those Twitch subs, get those Twitch Prime subs. We might even use Mixer or something like that. But if you guys, feel free to email me and be like, hey, Brian, I know this about Twitch. Or if you know someone who uses Twitch, I know like some people, like I know some decently. Very, very quick story. I think I can show it off. Yeah, there is, I'll show you that. You guys may not know this, but we have a kind of famous, and then we'll finish this. We at UTK had a guy, there he is, Fatty, that is his name. It's F-A-D-I, but he came up with the channel Barack's Dubs, and his channel now has over 1 million. See, this is a few years ago, and it had a little under 1 million, but so there he is. It's pronounced Fatty, and really great guy. But he came up with this channel. I met him when he was like a freshman. He was walking through Presidential Court, and his friend had like this crazy shirt on. It was almost like a Hawaiian shirt, and his friend looked like he was from like the 70s. And so I was like, that is such a cool shirt. And his friend was like, oh, thanks. And I was like, hey, blah, blah, blah. And I talked to them. This is like 2011. And he was like, oh, my name is Fatty. And I was like, Fatty? And he was like, yeah, that's how it's said. And I was like, oh, okay. He's a really fun guy and really entertaining. But he came up with the channel, and you look at his videos now, and they have, like millions of views. So check out, have you guys ever seen this, Barack's Dubs, where Obama would sing songs? But yeah, so he made up this channel and stream Animal Crossing. I know I should get, is it New Horizons? I heard people are getting mad. People were doing like time cheats in it or something. You've never heard of Barack's Dubs? Here, we'll take one quick look at it. I can't obviously, if I show it, YouTube, Barack's Dubs. I guess it was super popular, like, when Obama was president. But check it out. Wow. He's got 1.5 million subs. So he's way past the million. But if you go to like his top videos right here, so it's all different songs. Oh, and he's posting new videos. Oh, they're not getting nearly as many now, but he's got all different videos, 4.6 million views. I can't imagine having a 1 million viewed video, but this is his channel. But yeah, so cool stuff. Fatty did an amazing job with this. He was on like different news channels and stuff. Like I think he was on Good Morning America. But yeah, cool guy, and did some really awesome stuff. And he's given me a little bit of advice and stuff like that too. But that's got it. Okay, predictions. So let's do right here. Let's run the predictions. That's just going to store our predictions. Let's take a look at those predictions. There's what we predict people to be. And so we're predicting yeses and nos. Let's make a confusion matrix right here. Okay, cool. So what do we get with our confusion matrix? So much stuff. It's important to know how to read the confusion matrix. This is the predictions. I think I was doing it differently yesterday. You can put them in different orders. But right here we have an accurate prediction, and here we have an accurate. So you can look at the accuracy and figure it out yourself, because we predicted 48 people accurate and we predicted 12 people accurate. I'm going to ask a really hard question right now. This is another 1,000,000 question, huge points today, and we're almost done. We'll finish up here in another 5-10 minutes. But I want to know how many people actually have diabetes. How many people actually have it? So the way it's written right here, can you read it and tell me how many people actually have it, and what would you predict for everybody with the naive model? So with the way this is written, can you tell me? And this is the holdout. 27, you are correct, because you have to go through the reference right here. So you have to go down the reference, because the reference is the actual. So you are correct. Great. You guys are doing excellent work. You have to be like, this is the top part when you go down. Like, these are the reference yes, these are the reference no, these are the predicted no, and the naive would predict no. Yep, exactly. And we usually construct the naive from the training data. So even though we're looking at the holdout, it shares a similar pattern. And that's the weird thing. That's why sometimes your holdout data might be messed up. Like, it might have outliers and stuff you shouldn't have. So you can get a weird model from the training, from the validation data that you made your model from. You train your data, you validate your data, you make a holdout model, or you train it on the holdout. You test it on the holdout, excuse me. Talking too quickly. We've got confidence intervals right here, which are due to the uncertainty. P-value for the accuracy, good. We never talk about that. Kappa, I have no idea what McNair's test for p-value is. No idea. Sensitivity and specificity, I'm not huge fans of these. These are like your true positives, false positives, and all these things like this. It's just, when you talk about these in industry, I mean, you might put them in reports, but it's better to talk about, like, how many false positives we have, how many true positives we have, or to explain it in longer words. So you get so much information right here. Lots of great stuff. Then we look at the post-resample, the accuracy, and the ROC of the model. Cool. Why do I like this ROC right here? Does anyone remember our original ROC? Because I saw it and I said, cool. It's like, that's good. Why do I like this ROC of this model right here? What's good about it? Do you remember the original ROC? The original ROC was, is it this one's giving us ROC? I think this is gonna, that's the ROC on the training. So yeah, we should be able to, well, that's the whole thing. So we should go here. Yeah, there we go. Yeah, exactly. They're so similar. They're within like one standard deviation. Usually you expect your model to work worse on the holdout, but this model works virtually identical. And so do you think this model would do about the same job on new data? Like, if we gave this model even more new data, do you think it would do about the same job? If we gave this model even more new data, do you think it would do about the same job? Yes or no? Be like, no, I don't know. I don't have. Yes. Why do we think this model would do about the same on new data? Probably. Yeah, that's a good way to say it in statistics. Probably. We have good evidence. Because what is our good evidence that this model would work on another new data set? What is our good evidence that this model would work on another new data set? Any ideas? It was very close. I like that right there. The holdout, and that's the key. The holdout, this is like literally the point of predictive modeling. The point of predictive modeling is that we have to see if it works on new data. So when we get this right here, this post-resample, which I think this is an E1071 function right here. You can check to see which package it is by typing it. So it should be, oh, it's in caret. Of course it's in caret. It's a caret function. E1071, camera does. Yep, and that's exactly it. 100,000 points, both you guys right there. So we see if it works on new data, and if it works on new data, we assume it works on new data. I know it sounds crazy to say new data, but that would just be using the model again. Because think about the point of this. You're trying to you work for a healthcare industry, and you're trying to predict if people have diabetes. So diabetes, I can't say that word either. So you're trying to predict that. So you create this model, and you make it from people. You test it out on a validation by using k-fold cross-validation, and then you see if it works on new data. Now, that's not saying you go and test it on people without knowing the model works. You do like the holdout method where you see it works on new data before you bring it to like the doctors and be like, hey, this model works. They'll be like, well, how do you know it works? You'll be like, I already tested on new data. And they say, we gave you 500 observations. How did you get new data? It's So I'd love that as a test question. So the doctors say to you, we gave you 500 observations. How did you get new data? Someone put in the chat for one last million points, crazy points this morning. One last time, how did you get new data? They only gave you 500 data points. How did you get new data to test it out on? How did you get new data to test the model out on? They only gave you 500. Did you go out and like talk to people? Did you collect? We didn't want you to collect more data. How did you do that? How did you get new data? How did you get new data to test your model out on? How did you get new data to test your model out on? Who knows? Highlighting the answer. We did a holdout. Yeah, we created our own holdout. So you leave some data. That's exactly a million points, both you guys right there. You create your holdout. That's the point, is you make your own new data. You're holding out. You guys, great job, David, also. You're holding out some data. That's the point. So when you have new data, you're creating your new data to put the model on, which this sounds so counterintuitive to people to not use all your data to make your model. But how do you know if your model works? How do you know if you didn't what? I want to see in the chat. How do you know you did not what your model to the data? How do you know you did not blank do this? And your model will then generalize. How do you know you did not overfit? David, 100,000 points. Nice answer in the chat. How do you know you did not overfit? John also and Quinlan. So how do you know you did not overfit your model? The only way to know you did not overfit. Jessica also 100,000. And so much. Thank you guys for being here. But that's the whole point of this assignment. I hope this week's kind of topics now feel a little more. I hope these week's topics feel a little more kind of easier to understand. Who feels better about this right now? I know it was kind of a long, we did like a little less than 2 hour. Yes, sir. So, that's to John. But are there any last final questions right now? And I really appreciate everyone being here. We might try to do like Friday morning streams where we do lab. This was perfect. So glad to hear that. Yeah, I feel like I really like this format where I can see what you guys are saying and everything. It's a lot of fun. And did you guys get 100 on the lab? Has anyone turned in their lab and gotten 100? Yeah, I know. We'll probably do Friday morning streams. I'm going to send the schedule out in the next things, and so John and I will be talking 4 and everything. Has anyone turned in the lab and gotten 100? I can take a look at the answers. If you turned in the lab and got 100, if anyone confirmed they got 100, then we'll be good to go. And these are recorded, so people can kind of fast forward through. But sorry, and I know right now. I think if you're watching this right now, I think we're basically done. I'm gonna see if anyone has any questions, and we're gonna see if people got a great grade on it, because that's when we want to get great grades. So let me look at the questions on it. Friday morning streams. Now I miss Jason. He would always sing everything. Questions. Okay, what is the AUC? Let me look. Okay, yeah, the AUC of the wine model. I think we did on the wine. So, and then you're supposed to get the mean of that. Yeah, okay, let me show that one. And it should be. Yeah, okay. It should be. There we go, right there. So that is the answer right there, John. I wonder if I can update that. Update answer. Let me update this. Oh, is it going to do weird things? Oh, I shouldn't do these things. Let me see if I can add in a new answer. Okay, what answer did you get, John? What answer did you get? You might have to resubmit it, but this will help everyone out. What answer did you get? Because you're probably getting a correct answer just based on your randomness. So what answer did you get? Thank you, John, for helping out with this. You said it way earlier. Way earlier. So 0.354. Okay, let me put that in here. Exact answer. Wait, is this the right one? No, that's the wrong one. Wait, I don't want to update that answer. Okay. Add another answer. There we go. Okay, cool. Update question. Okay, it worked. Okay, there we goes that. If you put it in now, it should accept it. So I think I'm showing the answer here, but I'm also, so that's got that. And then we look at the other ones to make sure everyone has all those. We have that, and then I have to save this afterwards. Did everyone get use threefold, report the accuracy of the cross-validation? So we need the accuracy. Where do we get accuracy? Here's the, I'm just looking, oh, that's way high. So here's where we did the accuracy, I believe. No, that's AUC. Here's where we did the accuracy. Yep. Okay, so that one's the accuracy. So that's in the video. It's to 4 decimals. Report the cross-validation AUC. And I think that's what we all got. Let's make sure. Yep, that's what we got right there. What is the accurate hold out accuracy? And then there's multiple answers. What is the holdout accuracy? What is the AUC? And I think we have all this right here. Which one do you not have right now? Which answer do you not have right now? The question 5. So question 5 is the, sorry, so many things. Question 5 is the, it doesn't say the question numbers. 1, 2, 3, 4, 5. Is it, what is the holdout accuracy? What is the AUC accuracy on the holdout? Is that the one you're talking about? Wait, 3, 4, 5? So there is the AUC of the curve, and then we should have the accuracy right here. That makes sense right there. the repeat the cross-validation, but report its AUC. So we did the AUC earlier. The AUC is right here. And there's the AUC. AUC is ROC. And then using threefold cross-validation, report the accuracy. And we did the accuracy right here. And there's the accuracy. So David, did you get it now? How's it doing? Christian, are you good? Make sure to look at each part. I might kind of put a little bit of a mystery in here. But okay, so you got it? Okay, good. So everyone should have all the answers right now. So can we confirm that Brian has given away all the answers? So they should be released later today. Sorry it's taken so long, Christian. Sorry so long, I know. I've been wanting to make sure when we release them, everything's good. And everything's been so busy. But I got an 8 out of 10. Which one did it say which one you missed? You should be able to get 100. Does it say which one you missed? If you tell me which one you missed. Question 5? Question 5, did you put in the answers? It wants for question 5, the accuracy. And so the accuracy on the holdout. Now this is the accuracy on the holdout. Make sure you're doing accuracy on the holdout. So the accuracy on the holdout is going to be this right here. Oh, I see why. Well, that's going to be interesting. Does it say... Oh, it says without rounding. Can I update that? Does everyone see 3 digits? No, only 3 digits. Only 3 digits. So it says keep 3 digits without rounding. So that's the issue. So 3 digits without rounding. So it'll be 0.759, 0.835. So very sorry that... Does that make sense, David? I know, right? It's so specific. Christian, what did you get wrong, Christian? We'll correct it. I know, it's so specific. And if you ever feel like be like, hey, Brian, can you check this? Hey, can you look at this? I'll look at everything. Looks like we might be good. Christian, and then did you fix it? I know, it's so specific. It's like, keep 3 digits without rounding. It's like my Pearson all over again. I think that's got it. Well, awesome. Did David and Christian, did you get a 10 out of 10 now? And make sure you remember, it's not just getting the points here. It's remembering, like, knowing what accuracy means, knowing what AUC means, knowing how we compute these things, all these good things right here. I think that's got it. We'll confirm that David and Christian, anyone else got 10 out of 10s, and we'll take your guys' questions. But that's how you do all the code. Get our brains warmed up here this morning while we do the activity. Have a little bit of fun. How do we do, David and Christian? Pretty good? How many people do we have watching? Number four is repeat the cost validation, but report its AUC. So we need to do the AUC here, making sure. So we've got right here. This is, here it is right here. This is number 4. And there is the AUC. Just make sure to round it to 4 decimals. Got a 10? Yep. So can confirm. There we go. So this is the code for number 4. And that's got it. I think that's got it. If everyone has everything they need. But so, yes, David, great job. And great job, everybody. A lot of good work this morning. So we are good to go, I think. How many people do we have watching? 11 people. That's awesome. So for, just doing some 474 work. Well, cool. I think that's got it. If anyone else has any last questions, say them, because I'm going to head off and get a little food here and then get ready to start streaming again. Okay. Talk to everyone later. See you on Tuesday or Monday when I'm streaming. Bye.